Hello AI enthusiasts, welcome back to our channel. Today, we are diving into the world of machine learning, a core component of artificial intelligence that's revolutionizing numerous industries. By the end of this video, you'll have a solid understanding of what machine learning is, how it works, and why it's so important. Machine learning is a subset of artificial intelligence that involves training algorithms to learn from and make predictions or decisions based on data. Instead of being explicitly programmed to perform a task, these algorithms improve their performance by learning from experience. Essentially, machine learning allows computers to learn and adapt without following specific instructions for every task. An algorithm is a set of rules or instructions given to a computer to help it solve a problem or complete a task. Think of it like a recipe in cooking. It provides step-by-step directions on how to achieve a desired outcome. Data refers to the information or facts that the computer uses to learn and make decisions. This can include numbers, text, images, or any other type of information that can be processed by a computer. In our cooking analogy, data would be the ingredients used in the recipe. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's break each of these down. In supervised learning, the algorithm is trained on a labeled dataset. This means that each example in the training set is paired with an output label. The goal is for the model to learn a mapping from inputs to outputs. For example, if you're training a model to recognize cats and dogs, you provide it with many labeled images of cats and dogs. Over time, the model learns to classify new images correctly. Think of it like a teacher supervising students' learning. The labels are the correct answers provided by the teacher, which help the model learn the patterns. Unsupervised learning involves training on unlabeled data. The algorithm tries to identify patterns or structures within the data. Clustering is a common task in unsupervised learning. For instance, a company might use clustering to segment customers based on purchasing behavior without predefined categories. Imagine sorting a box of mixed buttons into groups by color and size, but without any guidance. The algorithm figures out the groupings on its own. Reinforcement learning is inspired by behavioral psychology. Here, an agent learns to make decisions by performing actions in an environment to maximize some notion of cumulative reward. This type of learning is used in various applications, such as training robots to navigate or AI systems to play games like chess or Go. It's similar to training a pet with rewards and punishments. The pet learns to repeat actions that get rewards and avoid actions that get punishments. Now let's dive into some key concepts and terminology in machine learning that you need to know. The dataset is usually split into two parts: the training set and the testing set. The training set is used to train the model, while the testing set is used to evaluate its performance on unseen data. Think of the training set as the study material for an exam, and the testing set as the actual exam questions. The goal is to see how well the model has learned from the study material. Features are the input variables used to make predictions, while labels are the output variables or the target you're trying to predict. In the cat and dog example, the features might be the pixel values of the images and the labels would be cat or dog. Overfitting occurs when a model learns the training data too well, capturing noise and details that don't generalize to new data. Underfitting happens when a model is too simple to capture the underlying patterns in the data. The goal is to find a balance where the model generalizes well to unseen data. Overfitting is like memorizing every question in a study guide without understanding the material, while underfitting is like barely studying and missing important concepts. Common metrics for evaluating machine learning models include accuracy, precision, recall, and F1 score. These metrics help us understand how well our model is performing. Accuracy is the percentage of correct predictions. Precision is the accuracy of positive predictions. Recall is the ability to find all positive instances. F1 score is a balance between precision and recall. Let's walk through a simple example to see how machine learning works in practice. First, we collect data. Suppose we want to create a model that predicts house prices based on features like square footage, number of bedrooms, and location. We gather a dataset with these features and the corresponding prices. Next, we pre-process the data. This involves cleaning the data, handling missing values, and normalizing or standardizing the features. Cleaning the data means removing errors or inconsistencies. Normalizing or standardizing means adjusting the values to a common scale. We then choose a machine learning model. For this example, let's use a linear regression model, which tries to find the best fitting straight line through the data points. Linear regression is like drawing a line that best represents the relationship between the features, like square footage and the target, which is the house price. We train the model using the training data, allowing it to learn the relationship between the features and the target variable. Training is like practicing with the study material to understand how different features affect the house price. After training, we evaluate the model on the testing data to see how well it performs on unseen data. We use metrics like mean squared error to quantify the model's accuracy. Mean squared error measures the average squared difference between the predicted prices and the actual prices, giving us an idea of how far off the predictions are. Finally, we can use the trained model to make predictions on new data. For instance, we can input the features of a new house and predict its price. It's like using the learned material to answer new exam questions accurately. Machine learning is applied in various fields, revolutionizing the way we solve problems. Here are a few real-world applications. In healthcare, machine learning is used for predictive analytics, personalized treatment plans, and early disease detection. Predictive analytics helps forecast health trends. Personalized treatment plans tailor medical care to individual patients. Early disease detection identifies diseases at an early stage. In finance, it's used for fraud detection, algorithmic trading, and risk management. Fraud detection identifies fraudulent transactions. Algorithmic trading uses algorithms to trade stocks. Risk management assesses and mitigates financial risks. In transportation, machine learning powers self-driving cars, optimizes routes, and improves safety. Self-driving cars navigate without human intervention. Route optimization finds the best paths for travel. Safety improvements reduce accidents. Streaming services like Netflix and Spotify use machine learning for recommendation systems, personalizing content for users. Recommendation systems suggest movies or songs based on user preferences, enhancing the viewing or listening experience. Machine learning is a powerful tool that's transforming industries and driving innovation. By understanding its basics, types, and applications, we can appreciate how machine learning is shaping our world. If you enjoyed this video, please like, share, and subscribe to our channel for more insights into AI and machine learning. See you next time. For more videos on AI and machine learning, check out our playlist. Follow us on social media for updates and behind-the-scenes content. See you soon.